In this video, we look at the correlation coefficient and the coefficient of determination. There are two ways to think about R squared. By the way, in simple regression, with just one independent variable, it's convention to use a lowercase r squared. In multiple regression, with more than one independent variable, the convention is to use an uppercase r squared. This code uses the LM function to find the regression between MPG and displacement and stores the result in the object named model. The summary function shows the regression results, and r squared is part of this output. One way to find r squared is to divide the explained sum of squares by the total sum of squares, and it's interpreted as the proportion of the variation in the dependent variable that's explained by the regression model. In this example, it equals 0.7183. There is another way of finding r squared, and it's based on the correlation coefficient, which is symbolized by the lowercase r, and it's a statistic that falls between -1 and +1. If there's a perfect negative relationship between x and y, the data points all fall on a negatively sloped regression line, and r will equal -1. If there's a perfect positive relationship between x and y, the data points all fall on a positively sloped regression line, and r equals +1. If there's absolutely no relationship between x and y, the regression line will be horizontal. The y-intercept will equal the mean of y, and r equals 0. We're going to find the correlation between the individual MPG observations, keep in mind these are our y values, and the predicted MPG for each data point using the regression model. Next, we're going to find the correlation coefficient squared. The first two lines of code tell R that our variables MPG and DISP are in the MTCARS dataset. Here we run the regression equation and save the results in an object named model. The names model line of code lists the contents of the model. One of the contents is named fitted.values. This is a vector containing the predicted MPG value for each data point. I put these values in an object named PRED, that's short for predictions. The line of code COR parenthesis MPG comma PRED parenthesis computes and displays the correlation coefficient for MPG and PRED. It equals 0.8476. Finally, I find the squared correlation coefficient, and it equals 0.7183. This is the same value we found earlier for r squared. In this video, we learned that the correlation coefficient is a relative measure of the nature and strength of the relationship between two variables. It always falls between minus and +1, and its squared value is another way of finding r squared. In later lessons, when we're using more complex predictive models, we will find r squared by squaring the correlation coefficient between the predicted values of the dependent variable and the observed values of the dependent variable, just like we did here. That's a quick look at the coefficient of determination. Thanks for watching.